Hello all. So we will solve for simple cubic structure first. So in simple cubic structure, along the edges of a cube, the atoms touch each other. We will assume hard sphere model. Hard sphere model is nothing but just like tennis ball we are having. We are keeping that atoms in the respective positions. So this is a face of a cube, and the edge I have represented it as A, and the atom looks like this, a circle. In this atom is a sphere, the sphere is, so we are able to see that there is two R, one R for the first atom and the second R for the second atom. So A is equal to 2R. This is a relation we obtain for simple cubic. Next, carrying forward this relation, we have to calculate the atomic packing factor. We'll go to the atomic packing factor formula: N into volume of atom divided by volume of unit cell. N for simple cubic is 1. N is nothing but number of atom in a unit cell. So I will show you how is the unit cell of simple cubic look. This is our simple cubic unit cell. We have 8 atoms, one atom at each corner. So each atom at the corner is shared by 8 other unit cells. So 8 into 1 by 8 is equal to 1. So 1 atom for n. That means 1 atom per unit cell for a simple cubic structure. Volume of atom, we are assuming hard sphere. So volume of a sphere is 4 by 3 pi r cube. And volume of unit cell is A cube. We know A is equal to 2R. This relation we must use it in A cube. So 4 by 3 pi r cube divided by 8 r cube. In A we are substituting 2R. So 2R whole cube is 8R cube. Now when you do this, you will get as pi by 6. Now never do mistakes in elementary mathematics. So 0.5, which means 30, 14, 2 times 12. So it is 0.52. APF of simple cubic is just very easy, 0.52. It is a fraction, and if you want in percentage, then 0.52 into 100, which is 52%. Thank you. We will see in our next 3-minute video.